Hi, my name's Cameron Smart. I'm the Managing Director of Cammel Consulting. So Cammel Consulting is a service provider to the mining industry, providing project management and construction management services. We've been working on the Ensham site for about 4 years, and in that time we've been able to identify a number of issues that face Ensham and the mining industry as a whole. We found there was a deficit of topsoil. There was a huge amount of contaminated water on site, and in our process of actually doing the rehabilitation, we observed there was further issues around being able to get a guaranteed establishment of pasture. Because of the lack of root mass and grass growth or established pastures, we were finding that when we did have a significant downpour, a significant rainfall event, we were getting a lot of erosion. That was causing an issue for the mine because they then had to rework those areas that have already been rehabilitated. On top of that, they were losing topsoil, which they've already got a deficit of. It was being washed away and they'd have to replace it. We identified an area on site that hadn't been rehabilitated but had really good grass growth. And the question was asked is, why can't we use that sort of material as our topsoil? It was a natural fit that Alison within SoilCyclers can take soil and unsuitable soil and convert it into a growth medium.
So SoilCyclers has a background in ameliorating topsoils, making geotechnical amendments to subsoils, and also fixing contamination issues in soils. Some of the materials we saw at Ensham were actually similar quality to the sodic dispersive soils that we see beside the highways across multiple sites around Queensland. We took samples from 20 different overburden stockpiles across the entire length of the site. We took those to the lab and we analysed the results and came up with amelioration strategies for all of them. For the purposes of this, we chose 2 of the poorest materials so that we could prove that it could be done with any material. We sourced ameliorants locally because we wanted to reduce the distances materials were travelling to the site and also to keep the costs reasonable so that this would be suitable to do on a large scale for revegetation of an entire mine site. The amelioration was done using one of our mobile trommel screens. The overburden stockpiles had been sitting for many years. They had large boulders and rocks in them that we needed to remove to make the material more like a topsoil. And we also needed to aerate those stockpiles because they'd been sitting for a long time.
Alison was able to provide the topsoil that we needed, but without water, we weren't able to actually guarantee an end result in the rehabilitation process. We had an abundance of pit water on site, which in its current format wasn't able to be used. I was able to contact Butch and bring Butch on board with some innovative ideas about how we could actually treat that particular water.
In discussions with Alison and Cameron, we came up with a methodology of trying to treat the water to a suitable level, and that was utilising vegetation, so bioremediation, passive treatment, obviously no power or anything like that or chemicals required. With a bit of research, I've identified a couple of plant species that potentially could work in that space. Both have demonstrated their ability to store salt in their cells, and we were planting those out into floating wetland structures. So species A, it was the slow-growing species. We were able to demonstrate that it did store salt in its cells, which was a really good positive out of that. Species B, it struggled in the floating wetland space. It's more inclined to excel in a cropping space. So we'll be looking at utilising that species in a cropping environment to uptake that salt out of the water.
With the first 2 issues solved, the other one was the actual seeds that we were using on site. So we wanted to target seeds that had a higher tolerance to salt. So we looked at seeds that were on site growing in existing pit water. We also did some germination trials. So from that, we were able to identify a select seed mix to use on site. So the trial's been a success. We've been able to establish pastures on our ameliorated spoils, utilising the seeds that we've selected and watering it with straight pit water and partially treated pit water.
It's very innovative for our industry. It's something that we've kind of spoken about on site for quite some time, to be able to utilise our spoil resources and turn it into an actual resource of topsoil.
I think this project is a great opportunity for the mining industry to demonstrate that sometimes you can do more with rehabilitation. Sometimes it's not just about growing grass or pasture. You might actually be able to do more with this land post-mining and create new industries around the mine sites where you've been working.
So I've been involved in the mining and civil industry for about 30 years, and in that time I've seen a lot of the issues that have faced the mining industry. I understand the challenges that mine sites face when it comes to rehabilitation, and yeah, to be able to come up with a solution that works for a mine site, that's cost effective and sustainable is what we're all about.